Welcome to Section 7.3, Formulas Involving Polygons. Our objective is to use formulas to apply to polygons. For our homework, we have page 309 through 312, numbers 1 through 7, 8 to 16 evens, and 23. First and foremost, it's important for us to know polygon names. We're not always going to be given just the number of sides, but polygons will be given using their official names. So if it has 3 sides, it's a triangle, 4 sides a quadrilateral, 5 sides a pentagon, 6 sides a hexagon. Those are some of the more common ones. If it's 7 sides, it's a heptagon. 8 sides we know is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 12 sides is a dodecagon. N represents any number of sides. If it's not one of these listed up here, usually it's given with the number of sides / gon. For instance, if we have 21 sides, that would be called a 21agon. And now we start with our theorems. Our theorems for this section have the formulas embedded in them. So our first theorem says, the sum of the measure of the interior angles of a polygon with n sides, so any number of sides, is given by the formula n minus 2 times 180. Our next theorem says the sum of any exterior angles is always 360. So it doesn't matter how many sides it has, when you add up those exterior angles, it's always going to equal 360 degrees. And last but not least, the number of diagonals of a polygon with n sides is given by the formula n squared minus 3n all over 2. And now we start with our first example. We're going to find the measure of the interior angles of the figure. So first and foremost, it's important for us to know how many sides this figure has. So we're going to count them up. 1, 2, 3, 4, 5, 6 sides. Make a little note of that. 6 sides, this is called a hexagon. We're trying to find the interior angles, which is known using the formula n minus 2 times 180. N represents the number of sides, and it has 6 sides. 6 minus 2 times 180 is actually 4 times 180, which means that it's going to be 720 degrees. Do you have any idea why that formula works? Well, let's explore it really quickly. If I look at all diagonals stemming from one vertex, I have 1, 2, and 3 diagonals. Those 3 diagonals form a total of 4 triangles. Each triangle we know is going to equal 180 degrees. So 180 plus 180 plus 180 plus 180 is why we have 720 degrees. For our next example, we want to know what is the number of diagonals that can be drawn in the figure. So again, we want to first start off by determining how many sides it has. So here we go. 1, 2, 3, 4, 5, 6, 7, 8 sides. So here we go. Our formula to determine the number of diagonals is going to be n squared minus 3n all over 2. So let's plug in the pieces. We know that the number of sides that we had here was 8 sides. 8 squared minus 3 times 8 all over 2 gives us 64 minus 24 over 2. 40 over 2 leaves us with 20 diagonals. So let's kind of see why. We're going to do these in different colors. So let's draw all of our diagonals. We got 1, 2, 3, 4, 5 in green. We have 6, 7, 8, 9, 10 including my red, 11, 12, 13, 14, and this one's already connected. We have 15, 16, 17, this one's already connected, this one's already connected, 18, 19, already connected, and we got one more. A total of 20. We have a total of 20 diagonals in this octagon. For our last example, it asks us to work backwards. If a polygon has 1080 degrees, what's its name? That 1080 degrees is actually our interior angles. So let's use our interior angle formula. The number of sides minus 2 times 180 equals the sum 1080. We have two options, either to distribute the 180 to both sides, or we're going to divide both sides by 180. So it cancels out, which leaves us with n minus 2 equals 6. Last but not least, add 2 to both sides, and the number of sides is going to be 8, and an 8-sided figure is an octagon. You try those last two, see what you got. Here we go. N minus 2 times 180 equals 2880. You take it from there. Hopefully for that second one you got an 18 again. There's no special name. For our last one, if you have to do this formula, shame on you. 360 degrees is a quadrilateral. Don't write down square. A square is a special type of quadrilateral. Any figure that has 4 sides, whether it's a kite, a trapezoid, a parallelogram, or a square, they're all under the quadrilateral umbrella. Last but not least, our homework answers. For homework, we had 1 through 8, 10 to 16, the evens, and 23. If you have any questions, please make sure we ask it tomorrow. And as always, have a good day.